Good morning, students. This is Shesh Babu, Physics IIT and NEET faculty. I had 23 years of experience and previously I worked at Narayan and Chaitanya. Now I am associated with SICD Shraddha Institutes in Ichilkaranji. Very glad to meet you. Today we will start with current electricity. Initially we will discuss with Kirchhoff's laws. Before introduction of the Kirchhoff's laws, what is the need of introducing Kirchhoff's laws? Let us see. First of all, we'll discuss about the Ohm's law. Ohm's law will be used to find the current flowing through the circuit. If any simple circuit is there, for example, this is a simple circuit. Let us assume the resistance of this is 20 ohms. Here battery voltage is 100 volt. Then what is the current flowing through the circuit will be? Ohm's law is V is equal to IR. Then I is equal to V by R. V value will be 100. R value will be 20. By substituting these two values, we will get I value is 5 amperes. So current flowing through the circuit will be 5 amperes. For example, if we consider any complicated circuit, let us assume 3-4 batteries are there, 4-5 resistances are there in the circuit. Here there is a battery, here there is a battery, here one resistor is there, this resistor is there, here one more battery is there. Like this, any complicated circuit is there. What is the current flowing through the circuit through every branch? To find that, Kirchhoff's laws will be used. Two Kirchhoff's laws are there. First one will be Kirchhoff's first law. What is that Kirchhoff's first law? Let us see first. First of all, Kirchhoff's first law. This law will be also called as Kirchhoff's current law. This law will be also called as junction law. All are same only. Kirchhoff's first law, Kirchhoff's current law, Kirchhoff's junction law. What is that law? See, this law is saying the sum of the currents reaching the junction is equal to sum of the currents moving away from the junction. For example, there is a junction. Junction means where two, three wires are meeting. That will be called as the junction. Here at this junction, these three wires carrying current are meeting. Let us assume through this wire current I1 is coming, through this wire current I2 is coming, through this wire current I3 is coming, through this wires currents I4 and I5 are going out. This law is saying sum of the currents reaching the junction is equal to sum of the currents moving away from the junction. So I1 plus I2 plus I3. These are the currents reaching the junction. Currents moving away from the junction, that sum will be equal to I4 plus I5. So I1 plus I2 plus I3 is equal to I4 plus I5. In other words, we can write this one in this format. I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Or we can write it as sigma I value is equal to 0. So this is, if from this we can state the Kirchhoff's first law in another format also. What is that is the algebraic sum of all the currents at any junction is equal to 0. That is the word format of this. Sigma I is equal to 0 means the algebraic sum of all the currents at any junction is equal to 0. From this we can write Sigma I is equal to 0 means dq by dt is equal to 0. Anything's differentiation is 0 means that thing will be a constant. So therefore q is equal to constant. So this is in accordance with the law of conservation of charge. If q is constant means something is constant that we can say that is conserved. So this Kirchhoff's first law is in accordance with the law of conservation of charge. So totally what is Kirchhoff's first law? The sum of the currents reaching the junction is equal to sum of the currents moving away from the junction. Mathematically we can write at any junction sigma I value will be equal to 0. Next we will see Kirchhoff's second law. What is Kirchhoff's second law? Let us see about that. Now Kirchhoff's second law. According to this law, the algebraic sum of all the potentials in a loop is equal to 0. The algebraic sum of all the potentials in a loop is equal to 0. So what it is saying is sigma v is equal to 0. We can write it as sigma IR sigma E value is equal to 0. For example, in that circuit, some resistors are there, some batteries are there. So, the sum of the algebraic sum of all the EMFs and all the potential drops across the resistors is equal to 0. In other words, the algebraic sum of all the EMFs, all the potential drops as all resistors is equal to 0. That is Kirchhoff's second law. For this sign convention, we had to apply to understand this. What is that sign convention and how to apply the Kirchhoff's second law? Let us see about it. What is the sign convention? Here we have to use what is the sign convention. Here point A is there. Let us assume point B is there. In between this one resistor is there, let us assume. Here current is flowing from A to B. Means what will happen? A is at high potential and B is at low potential. That's why current is flowing from A to B. We can write VA. Here let the resistor is R. So minus IR is equal to VB. So across the, if we are moving in the direction of the current, if we are moving from A to B, VA minus IR is equal to VB. For example, if we are moving from B to A. How to write this is VB. Our moving direction is from B to A, but current is moving opposite to our moving direction. So that's why IR is equal to VA. Result will be the same. VA minus VB, here IR. Here also VA minus VB equal to IR. So same results we will get whether we are moving in one direction. If we are moving in opposite direction also same results will come. What is the sign convention here we have to follow? Across the resistor, potential drop will be minus IR if we are moving in the direction of the current. If we are moving opposite to the direction of the current, then potential drop will be positive. Next, for example, there is a battery here of EMF E. Then what will happen? If we are moving from A to B, means we are moving from negative to positive terminal, then battery means we are going from low to high. Here this is negative, this is positive, low to high, then we can write its EMF is plus E. For example, if we are moving from B to A, means we are going from positive to negative, means high to low we are going. So its EMF will be, we have to write it as negative. Let us do some problems basing on this to understand and how to apply this Kirchhoff's law to, let us discuss some problems relating to this. So what is Kirchhoff's second law? What we are discussing, in any closed loop, the sum of all the potentials is equal to zero. That is Kirchhoff's second law. How to apply this law? We will do some problems relating to this. So let us consider this circuit. Here, this resistance, let it be R1. Let this resistance is R2. Let this resistance is R3. Let this battery CMF is E. Then this is a closed loop. Let us assume this is A, this is B, this is C, this is D. Then let assume current flowing through the circuit is I. So A to B in the loop A, B, C, D, A. A to B means we are moving in the direction of the current. So that's why drop across AB will be minus IR1. Here minus IR2. Here also current is going like this. We are also moving in the same direction. Minus IR3. So here negative to positive we are moving means CMF will be positive. The total will be equal to 0. Then I into R1 plus R2 plus R3 is equal to E. I is equal to E by R1 plus R2 plus R3. That is the current flowing through the circuit. We apply Kirchhoff's second law. Let us take one more circuit here. This EMF is E1. This EMF is E2. Let this resistance R2. Let this is R1. Let this is I. Apply Kirchhoff's law. Find the current in this circuit. So consider any point. You can take any point A to B, A, B, C, E, like that we can consider. So if we consider the loop A, D, C, B is a closed loop. To apply the Kirchhoff second law, we need the closed loop. So A to B, there is no battery, there is no resistor. D to C, we are going in the direction of the current. So drop will be minus IR. C to B, drop, there is no current element. Next B to A, minus IR2. Here, low to high we are going. So plus E2. High to low we are going minus E1. So again here minus IR1 is equal to 0. So E2 minus E1 is equal to I into R plus capital R plus small r1 plus small r2. Then we can write I is equal to E2 minus E1 by capital R1 plus R1 plus R2 to find the current in the circuit. Let us take one more example to understand this Kirchhoff. Okay, consider this a circuit. Let us assume this resistance is R1, this is R2, this EMF is E1, this EMF let it be E2, let it be R. So here take A, B, C, D, E, F, G, H. So how to apply this Kirchhoff's second law for this? We'll consider the loop. In loop A, B, C, G, H, F, A. This is the first loop. Then let us assume this is the current coming from it. This is the current coming from it. This is the total current. So A to B we are going. Means high to low we are going. So minus E1. And we are going opposite to the direction of the current. So plus IR1. Again, if you come like this, plus IR is equal to 0. If we apply for the loop, we'll take like this F, H, G, C, D, E, F. Then what will happen? We are going in the direction of the current. So minus IR minus this current will be I2 here. This current will be I1 here. So minus I2 R2 plus E2 is equal to 0. Like this, we can apply the Kirchhoff's laws, and using this 2, we can find I1, I2 and I values, applying the Kirchhoff's second law. So that is Kirchhoff's second law. Next, after completion of this, let us discuss about Wheatstone bridge will be used to find the unknown resistance. Any one resistance is there. What is the unknown value of the resistance? To find Wheatstone bridge will be used. How to use? Wheatstone bridge will contain 4 resistors. Here one resistor, here one more resistor, here one resistor. It will have four resistors, PQRS. In between let these junctions are A, B, C, D. Between the points B and D, one galvanometer will be connected. And between the points A and D, one battery and one tap key will be connected. Current, let us assume I is the current coming from the battery. Let the EMF of the battery is A and tap key let it be K. Four resistors are there, PQRS. Galvanometer resistance will be G. Here current will be divided into two parts. Let the currents are I1 and I2. Let the currents flowing through the galvanometer let it be I3. Let the current flowing through this is I4. Let the current flowing through this is I3. Let it be I4. Totally the net current let it be I. Then how to apply the Kirchhoff's laws to find the currents flowing through this and what is the balancing condition of the Wheatstone bridge? Let us discuss here. So we'll consider the loop A, B, D, A. In this loop, initially we are going from A to B. So that will be drop minus I1P. Later we are coming from B to D. So that will be also drop minus IgG. Here we are going opposite to this. So I2R is equal to 0. So what will happen? I1P plus I2G is equal to IgG is equal to I2R. Let it be equation 1. Consider the loop BCDB. In this loop, initially we are going from B to C, so the drop will be minus I3Q. Next we are going from C to D, means we are going opposite I4S. We are going opposite here, so we can write here IgG is equal to 0. So here I3Q is equal to I4S plus IgG. Let it be equation 2. If the bridge is balanced, when we will say bridge is balanced means current flowing through the galvanometer will be equal to 0. Then we can say bridge is balanced. When bridge is balanced, Ig value will be equal to 0. Then we can write I1P is equal to I2R, let it be equation 3. I3Q is equal to I4S, let it be equation 4. But here what will happen means, because there is no current flowing through the galvanometer, I1 value will be equal to I3, I2 value will be equal to I4. So here I1 value will be equal to, if you divide this, we'll do one thing. 3 by 4 if you do I1P by I3Q is equal to I2R by I4S. But I1 is equal to I3, I2 is equal to I4. So we can cancel these two. P by Q is equal to R by S. This is the balancing condition of Wheatstone bridge. So when Wheatstone bridge is balanced, P by Q is equal to R by S. What is the use of the Wheatstone bridge means? Wheatstone bridge will be used to find the unknown resistance. For example, Wheatstone bridge circuit will be like this. Already we know the values of P, Q and R, but we don't know the value of S. So here by adjusting the values of PQR, we can make current flowing through the galvanometer is zero. When galvanometer current becomes zero, then automatically P by Q is equal to R by S. By using that, we can find the value of S. That is about the Wheatstone bridge. Up to now in this class, what we discussed is Kirchhoff's first law, Kirchhoff's second law, and Wheatstone bridge we discussed. Kirchhoff's first law is saying the sum of the currents at any junction is equal to zero. Kirchhoff's second law is saying the algebraic sum of all the potential differences in a closed loop is equal to zero. Mathematical form of Kirchhoff's first law is sigma I is equal to 0. Mathematical form of Kirchhoff's second law is sigma IR is equal to 0 or sigma V is equal to 0. And Wheatstone bridge is saying when Wheatstone bridge is balanced, the condition to be satisfied is P by Q is equal to R by S. Let us discuss some problems basing on this. Then come to the material. We'll discuss problems basing on this. Page number 24, question number 84, let us discuss about this. What they are giving, a resistance is made by connecting two wires of same material of radii 2 meter and 5 meter, length 8 centimeter and 5 centimeter. The potential difference of 22 volt is applied to them. The potential difference on the longer wire is how much? Here two wires are there. This is longer wire. Its length is its length is 8 centimeter. Its diameter they given it as 2 mm. Here one more wire is there. Diameter is 5 mm. Its length will be 5 centimeter. These two are connected across a battery of 22 volt. Then they are asking what is the potential difference across the first wire, across the longer wire. So here R, we know the formula rho L by A, rho L by R square. They mentioned in the problem both wires are made with the same material. So they will have the same rho value. R1 by R2 is equal to L1 by L2 into R2 square by R1 square. L1 by L2 value will be 8 by 5. First wire length is 8, second wire length is 5, so 8 by 5. First wire radius will be 5 mm. So same units they will cancel, no need to convert the units. This will be 2 square. So 5 square means 5, 1, 5 will cancel, 4 2s will cancel. This value will be 10 by 1, R1 by R2 value. We know V1 by V2 is equal to R1 by R2 because in series current remains as the constant. So V1 by V2 is equal to 10 by 1. We have to find the V1 value. That's why you write it as V2 by V1 is equal to 1 by 10. We'll add 1 on both sides. 1 plus V2 by V1 will be 1 plus 1 by 10. V1 plus V2 by V1 is equal to 10 plus 1 by 10. This is equal to 11 by 10. V1 plus V2 is nothing but V. V value they given it as 22 is equal to 11 by 10. V1 is equal to then 20 volt. So the option will be fourth option. Answer is 20 volt. Next, one more problem we'll see. Problem number 86 we will discuss. What is it? Problem number 86. What they are saying. Here one circuit is there. This is voltmeter, this is ammeter. These resistances are 2 ohm and 2 ohm. This will be 2 ohm. This will be 4 ohm. This will be 4 volt having internal resistance 1 ohm. Then they are asking what is the equivalent resistance of the circuit. To find the equivalent resistance, no need to consider these components. These components won't affect the resistance. These 2 and 2 will be in parallel. Effectively, here one resistance is there. This will be 1 ohm. This resistance, battery's internal resistance. Here 2 ohm is there. 2 will be in parallel. Effective will be 1 ohm. And here it will be 4 ohms. So all the resistances are in parallel in series. So what is the effective resistance value means? Current started from here. See the direction of the current. Current started from here, going like this, going like this, going like this, and again coming to here. So all are same current is flowing, all are in series. Our effective value will be equal to 1 plus 2 plus 1 plus 4, 4 plus 4, that is equal to 8 ohms. That is about the second problem. Next we'll do 87. Please check the problem. The temperature coefficient of resistance of platinum is the its alpha value 3.9 into 10 power minus 3 Kelvin at 20 degrees centigrade. What find the temperature at which the increase in the resistance of platinum wire is 10% of the value at 20. Its temperature is increased. Then what happened? Its resistance also increased by 10%. So R2 minus R1 by R1. This value will be 10%. This value will be equal to 0.1. To what temperature it is raised? That they are asked. So there is a wire. It is at the temperature 20 degrees centigrade. Its alpha value will be this one. We increased the temperature so that its resistance is increased by 10%. What is the value of T2? We know the formula alpha is equal to R2 minus R1 by R1 into T2 minus T2. This is the formula. So here 3.92 into 10 power minus 3. R2 minus R1 by R1 value will be 0.1. T2 minus T1, T2 minus 20. This is. So we'll get this value T2 minus 20, 0.1 by 3.92 into 10 power minus 3. we'll get T2 minus 20 is equal to 100 by 3.92. After calculating, we'll get this value as 25.51. T2 is equal to T plus 25.51. So 45.51 is the answer. Option number 2 we will get here. Next, go to the next problem. Problem number 88. Let us see the problem. They gave one circuit like this. 2 ohm, 2 ohm, 2 ohm, 2 ohm. They mentioned these points are A, B, C, D. They are asking 4 identical resistances are joined as shown in the figure. The equivalent resistance between A and B is R1 and between A and C is R2. So between this, if we consider current is dividing here, in these 3 same current is flowing, so all these are in. So effective circuit will be like this. Here 2 ohm, this will be 6 ohm. RAB, they given it as R1. So this value will be 2 into 6 by 2 plus 6, 8. 2 fours will cancel. 6 by 4 means 1.5 volts. This is. Now for the same circuit across A and C means like this. These two will be in series, these two will be in series. So R2 is equal to 4 into 4 by 4 plus 4. This will be 2 ohms. They are asking what is the value of R1 by R2. R1 value we got it as 1.5, R2 value 2, we can write it as 3 by 4 also. So R1 by R2 value will be 3 by 4. That is question number 28. Next we will go for 89. They gave one circuit like this. Then in the galvanometer reading is 0. If the galvanometer reading is 0 in the given circuit, the current passing through this resistance is how much? Passing through the 250 ohm resistance is how much? That is the question they are asking. So here what we will get is this current is 0 means that no need to consider this circuit. You no need to consider this part. Just then I is equal to V by R effective. V value will be 12. This is 500 plus this is 250. 12 by 750. If we calculate this value 0.016 amperes. So first option we will get for this. In this 90, they gave one circuit like this. They are asking what is the effective resistance between A and B. So current will be entered like this. Current is leaving like this. Here this current will divide it into like this, like this, like this. So in this same current is flowing. So they will be in series. 3 into 3, 6. 6 will be in parallel. So that will be 3. So again if you redraw the circuit will be like this. These 3 will be 6. 6 will be again 3. 3 will be again 6. 6 will be again 3. 6 again with 6. This will be 3. 3 will be again 6. 6 into 3. So RAB consider 3 into 6 into 3 by plus 3. 18 by 9. This value will be 2 ohms. Oh. Next, 91. Let us see. One infinite ladder circuit they gave. These are not there. So here all are identical resistance. Here what we will get here is this is 1. I am assuming the effective resistance of the remaining infinite circuit, let it be X. Then again if we resolve the circuit, solve the circuit, 1X will be parallel. So effective of these two will be 1 ohm. This is 1 into X by 1 plus X. Then if we write REB value 1 plus X by X plus 1. Here RAB value is also equal to X, because what will happen, only just we are removing two resistances in an infinite circuit. That's why RAB value will be again X is equal to 1 plus X by 1 plus X. So this value plus X by 1 plus X. So X plus X square and cross multiplication 1 plus 2X. So X square minus X minus 1 is equal to 0. Solving this, x is equal to minus b means 1 plus or minus square root of b square minus 4ac by 2 into a. So 1 plus or minus 5 by 2. Minus 5 is not possible. So x is equal to 1 plus 5 by 2. So answer for this will be first option. Okay. Next, we'll see the next problem. See the next problem. Problem number 92. Here all resistances are equal to R, and R. What is the effective resistance between A and B? That is the question. So here, dividing this resistance like this. Then here R, here R. This will be R by 2, R. Again, R will be R by 2. So R by 2, those two will be in parallel. So what is the effective resistance of that 2 means R into R by 2 by R plus R by 2. So 3R square by 2 by 3R by 2. This value R by 3. R plus R by 3 will be 4R by 3. 4R by 3 will be parallel to this R. So 4R by 3 into R by 4R by 3 plus R. So R by 3, so 4R square by 3 divided by 7R by 3. This value 4R by 7. So this part effective resistance will be 4R by 3. Similarly, this part effective resistance will also be 4 by 3. So 4R by 7 plus 4R by 7. Effective resistance will be 8R by 7.